control a single-phase, 120 volts fractional horsepower exhaust fan from multiple locations using single-pole switches will not work as expected. A single-pole switch simply interrupts the hot wire. If you connect multiple single-pole switches in series on a hot wire leading to the fan, then activating any one of the switches will break the circuit and stop the fan, while the position of any other switch will have no impact. To achieve control from multiple points, you need to use multiple three-way switches. The key concept is that each three-way switch can selectively break or complete a portion of the hot wire path. When the three-way switches are connected in a specific configuration, a hot wire will only be connected when all of the three-way switches are in the same position, allowing the fan to operate. Let's examine a simplified schematic of this wiring configuration. Imagine a power source with two wires, Y-1 and Y-2. These wires connect to a series of three-way switches labeled three-way and three-way O, and so on, up to three-way X, with the final switch connected to the fan. Each three-way switch has three terminals, a common terminal, and two traveler terminals. Connect Y-1 from the power source to the common terminal of the first three-way switch, three-way on. Then connect Y-2 to the common terminal of the last three-way switch, three-way X. Now connect one of the traveler terminals of the first three-way switch to one of the traveler terminals of the second three-way switch. Continue this pattern, connecting a traveler terminal from each subsequent switch to a traveler terminal of the next switch in the series. Finally, connect one of the traveler terminals of the last three-way switch to the hot wire terminal of the fan. The neutral wire of the fan should be directly connected to the neutral wire coming from the power source. When all the three-way switches are in the same position, either all up or all down, electricity will flow from the power source to Y-1 through the common terminal of three-way on, through one of the traveler terminals of three-way on, through the interconnected traveler terminals of three-way O and subsequent switches, to the traveler terminal of three-way X, then to the common terminal of three-way X, through Y-2, and finally to the fan, causing it to operate. However, if any one of the three-way switches is flipped to the opposite position, the electrical circuit will be broken at that switch, interrupting the flow of electricity and stopping the fan. In summary, controlling a fan from multiple locations necessitates the use of three-way switches instead of single-pole switches. This configuration allows for the fan to be turned on or off from any of the control points. Three-way switches have three terminals. One is a common terminal and two are traveler terminals. The power flows to the common terminal. Depending on the position of the switch, power will be directed to one of the traveler terminals. Traveler terminals are connected to another three-way switch's traveler terminals. This allows for two different locations to control power to a load like the exhaust fan. In a typical household wiring scenario, you'll find three-way switches used to control lights from multiple entrances to a room, such as at the top and bottom of a staircase. The principles of operation remain the same as described for the fan control application. It's important to remember some key safety considerations when working with electrical wiring. Firstly, always disconnect the power at the circuit breaker before starting any wiring project. This will prevent electrical shock. Secondly, use appropriately rated wiring and electrical components for the circuit's voltage and amperage. Thirdly, ensure all connections are secure and properly insulated. Fourthly, if you are not comfortable working with electrical wiring, consult a qualified electrician. Finally, always follow local electrical codes and regulations. The NEC, or National Electrical Code, provides guidelines and standards for safe electrical installations. It's important to consult the NEC and local codes for specific requirements in your area. When working with 120-volt circuits, it is important to understand the potential hazards. Even relatively low voltages can be dangerous, so always exercise caution and follow safety precautions. A typical 120-volt circuit in a home can supply up to 15 amps or 20 amps, depending on the circuit breaker size. Always use appropriately sized wiring for the circuit's amperage rating. For example, a 15 amp circuit typically requires 14 American wire gauge or AWG copper wire, while a 20 amp circuit typically requires 12 AWG copper wire. It is also important to consider the voltage drop in long wire runs. Voltage drop occurs when the voltage at the end of a wire run is lower than the voltage at the beginning. This can be caused by the resistance of the wire. To minimize voltage drop, use larger gauge wire for longer runs. There are voltage drop calculators available online that can help you determine the appropriate wire size for your application. When connecting wires, it is important to use appropriate wiring connectors. Wire connectors are used to join two or more wires together safely and securely. There are different types of wire connectors available, such as wire nuts, pushing connectors, and crimp connectors. Choose the appropriate type of connector for the size and type of wire you are using. Always ensure that wire connections are tight and secure. Loose connections can cause overheating and electrical fires. After completing the wiring, it is important to test the circuit to ensure it is working properly. Use a multimeter to check the voltage and continuity of the circuit. A multimeter is a versatile tool that can be used to measure voltage, current, and resistance. To check the voltage, set the multimeter to the volts alternating current or volts AC range and connect the probes to the hot and neutral wires. The multimeter should read approximately 120 volts. To check the continuity, set the multimeter to the continuity setting and connect the probes to the two ends of the circuit. The multimeter should beep or display a low resistance reading, indicating that the circuit is complete. If you encounter any problems during the wiring process, stop and consult a qualified electrician. Do not attempt to troubleshoot electrical problems if you are not comfortable working with electricity. Remember, safety should always be your top priority. Working with electricity can be dangerous, so always take precautions to protect yourself from electrical shock. By following the guidelines and safety precautions outlined, you can safely and effectively wire a 120 volts fan with multiple three-way switches. The NEC, or National Electrical Code, provides detailed requirements for electrical installations. Here are some examples of NEC articles that may be relevant to wiring a 120 volts fan. 310.15 covers ampacity of conductors, specifying the allowable current carrying capacity of different wire sizes based on insulation type and installation conditions. 210.21 covers the use of cord and plug connected equipment, including limitations on the size and type of equipment that can be connected to a branch circuit. 250.118 covers types of equipment grounding conductors, specifying the types of conductors that can be used to ground electrical equipment. 430 covers motors, motor circuits, and controllers, including requirements for motor overcurrent protection, motor disconnecting means, and motor control circuits. 430.22 covers single motor, specifying the minimum size of conductors that supply a single motor. 430.52 covers motor branch circuit, short circuits, and ground fault protection, specifying the type and size of overcurrent protection devices required for motor circuits. These are just a few examples of the many NEC articles that may be relevant to wiring a 120 volts fan. Always consult the latest edition of the NEC and local codes for specific requirements in your area. When selecting a three-way switch for your project, there are several factors to consider. Firstly, choose a switch that is rated for the voltage and amperage of the circuit. A typical 120 volts, 15 amp switch should be sufficient for most fan applications. Secondly, consider the type of switch terminals. Some switches have screw terminals, while others have push-in terminals. Screw terminals are generally more reliable and provide a more secure connection. Thirdly, look for a switch that is UL listed or has other safety certifications. UL listing indicates that the switch has been tested and meets safety standards. Fourthly, consider the switch's ease of installation. Some switches are easier to install than others. Read reviews and compare features before making a purchase. Fifthly, consider the switch's appearance. Choose a switch that matches the style of your home. There are many different styles and finishes available. When selecting wire for your project, there are also several factors to consider. Firstly, choose a wire that is rated for the voltage and amperage of the circuit. As mentioned earlier, a 15 amp circuit typically requires 14 AWG copper wire, while a 20 amp circuit typically requires 12 AWG copper wire. Secondly, consider the type of wire insulation. There are different types of wire insulation available, such as THHN, THWN, and UF. THHN and THWN are commonly used for indoor wiring, while UF is used for outdoor wiring. Thirdly, choose a wire color that is appropriate for its function. Black wire is typically used for hot wires, white wire is typically used for neutral wires, and green or bare wire is typically used for ground wires. Fourthly, consider the wire's flexibility. Some wires are more flexible than others. Flexible wire is easier to work with in tight spaces. Fifthly, consider the wire's cost. Wire prices can vary depending on the type and size of the wire. When connecting wires, use appropriate wiring connectors. As mentioned earlier, there are different types of wire connectors available, such as wire nuts, push-in connectors, and crimp connectors. Choose the appropriate type of connector for the size and type of wire you are using. Always ensure that wire connections are tight and secure. Loose connections can cause overheating and electrical fires. When working with wire nuts, strip the insulation from the ends of the wires to be connected. Twist the exposed wires together clockwise. Screw the wire nut onto the twisted wires, ensuring that the wires are completely covered by the wire nut. When working with push-in connectors, strip the insulation from the ends of the wires to be connected. Push the exposed wires into the connector until they are securely held in place. When working with crimp connectors, strip the insulation from the ends of the wires to be connected. Insert the exposed wires into the connector. Use a crimping tool to crimp the connector onto the wires, creating a secure connection. There are also other advanced wiring techniques that can be used to improve the safety and reliability of electrical installations. For example, you can use arc fault circuit interrupters or RFCs to protect against electrical fires caused by arcing faults. RFCs are designed to detect arcing faults and interrupt the circuit, preventing a fire from starting. You can also use ground fault circuit interrupters or GFCIs to protect against electrical shock caused by ground faults. GFCIs are designed to detect ground faults and interrupt the circuit, preventing electrical shock. RFCs and GFCIs are required by the NEC in certain locations such as bedrooms, bathrooms, and kitchens. Another advanced wiring technique is to use surge protectors to protect against voltage surges. Voltage surges can damage electronic equipment, so it is important to protect your equipment with surge protectors. Surge protectors are designed to absorb voltage surges, preventing them from reaching your equipment. Whole house surge protectors can be installed at the electrical panel to protect all of the electrical equipment in your home. In addition to the above, it is also important to maintain your electrical system properly. Regularly inspect your electrical system for any signs of damage or wear. Replace any damaged or worn components immediately. Keep your electrical panel clean and free of obstructions. Do not overload circuits. If you are frequently tripping circuit breakers, have a qualified electrician inspect your electrical system. By following these maintenance tips, you can keep your electrical system in good working order and prevent electrical problems. Remember that electrical wiring can be dangerous, so always exercise caution and follow safety precautions. If you are not comfortable working with electrical wiring, consult a qualified electrician. A qualified electrician has the knowledge and experience to safely and effectively perform electrical work. Hiring a qualified electrician can save you time, money, and potential safety hazards. When hiring an electrician, be sure to check their credentials and references. Ask for proof of insurance and licensing. Get a written estimate before starting any work. Communicate your needs and expectations clearly. By following these tips, you can find a qualified electrician who can meet your needs. In summary, wiring a 120 volts fan with multiple three-way switches requires careful planning, attention to detail, and adherence to safety precautions. By understanding the principles of three-way switch wiring, selecting appropriate materials, following proper wiring techniques, and consulting the NEC and local codes, you can safely and effectively complete your project. Remember that electrical work can be dangerous, so always exercise caution and consult a qualified electrician if you are not comfortable working with electricity.